Let's calculate our AC resistance for gapped inductor that consists of Litz wire wound in one layer, where the winding consists of two wires connected in parallel. In order to set up such case, first we would need to, under the setup, choose either harmonic or inductive simulation type, because this homogenization method that we are going to use works at the moment only with harmonic and inductance simulation types. Then we would need to define the core. Under the windings, we would create two separate winding groups, where in each group we would tell the software that it consists of 10 turns. Each turn has one wire, and under configure of wire, here we would predefine what are the Litz wire properties. So under the RAC computational method, we would choose homogenization, which will basically set up a 2D simulation for us that will calculate the unit cell response to extramagnetic field and calculate 6 parameters that will be later used in the 3D simulation. So from the packaging, we have to choose hexagonal. Rectangular usually is used just for regular stranded windings. Next, you have to predefine what is a strand diameter, not wire diameter, but strand diameter. And in this case, it's 0.32. Next, you have to specify what is the maximum frequencies that you're going to solve. Depending on this frequency, will change the mesh refinement in this 2D simulation. And finally, you have to tell the software what is the fill factor. If you don't know, then you can click on the calculate. The software will take values from the values that you specified before. For example, turns per solid is 1, because in previous step we set it to be 1. Then cross section, this value is going to be calculated from the Litz wire diameter, Litz wire cross section. Strand type in this case is round. Strand thickness is taken from the previous step here, and number of strands we have to specify 7, because 7 strands are within this Litz wire. And we end up with the fill factor as shown here. We click accept, and then the software populates this value from the calculator. As a next step, we will assemble geometry. Then under the LMAG, as you can see, we choose both windings as a primary, because this is an inductor. And here, under the primary winding group, we choose parallel connection type for those two windings. It means that the software will calculate the winding, assuming that those two windings share the same voltage. So the same voltage will be applied to the terminals of those two windings. If we would have in series, then that would mean that the same current should flow through the both windings. Next, we will have to compute the mesh, solve the problem, and finally get results. This simulation took less than 5 minutes and calculated for 13 different frequencies. And as a result, we get inductance value, inductance distribution among the frequency. Notice that inductance is calculated in two methods using circuit and energy. Circuit is calculated by dividing complex voltage by complex current. Therefore, for zero frequency, we don't see any value, and energy is calculated from magnetic field energy. So here we will have the values for inductance, as well as we will calculate the RAC resistance depending on the frequency for this winding. Also, there are some general fields, such as magnetic flux, so as you can see that it doesn't depend on the frequency much, and the winding losses that do depend on the frequency. So the higher frequency, the higher losses would be, and also those losses are going to mostly concentrate near the gap. So for DC current, you would not see any additional losses due to proximity effect.